We normally start this problem if we wanted to find the area of a circle. What's the formula for the area of a circle? Area equals pi r squared. But what's the issue with setting it up like that? We don't know the radius. So we need to use the area of a sector formula. The area of the red sector, area of the red, is equal to what? Cody? Yeah, buddy. 135 over 360. Is that it?
Equals or times
What?
pi 48 squared.
No. So you're on the right track. It is going to be pi r squared, right? But in this case, I already said this. We don't know what value. That's super important. We don't know the radius. Do you guys agree that pi r squared is the same as what? Pi r squared is the same as what? The area of the circle, correct? So now if I solve this equation for capital A, will I not have the area of the circle? Try it. You know the area of the red section, so plug that in on the left. Multiply by the reciprocal and try to get the area of the full circle. This red section is only a piece of the whole circle. It's 135 degrees out of 360. So that's why we set up a ratio. We're saying if we take 135 over 360 and multiply it by the area of the whole circle, we'll get the area of the red section of the circle.
How would we know what the area of the circle is?
We don't. That's what we're trying to find. But what we do know is we know the area of the red section. It told us the area of the red section is how much? 48. So we're plugging in 48 to the left-hand side equals 135 over 360 times A. Does anyone remember how to solve an equation like this? Nick? What is the reciprocal? 360 over 135. Multiply by 360 over 135. Do it in your calculators now. The 130s cancel, the 360s cancel. So we just have area on the left, the right-hand side equals. Christian, what'd you get? No? Sophia, what'd you get? 128 is correct. But we're missing units. Feet squared. Why squared? It's area, baby. Dylan, was that a hand to answer or a hand for question? Okay. Hannah? Which part?
The area above, there's another equation that says area equals pi r squared.
Yep.
But that's, is that what you did?
No, it's not. So area equals pi r squared is what you should use if you have what value, Hannah?
The radius?
The radius. Did we have the radius here? No. So we have to use the area of this sector, which is the area of the red piece is the ratio of the arc over 360 times the area of the whole circle. So that's what I used here. I knew the arc was 135 degrees because the central angle was 135, and the area of the red section was 48. What's a polygon? Not 6 sides. Not 4 sides. It's a shape. But this specific shape has sides. Do you guys agree? Polygons have sides. Did circles have sides? Guys, a polygon is also not a 5-sided figure. What is a 5-sided figure? A pentagon. Polygons is like the blanket umbrella for all of them, okay? What is a hexagon? 6-sided figure. What is a septagon? 7. What about an octagon? 8. How many sides does a 4-sided figure, or what do we call a 4-sided figure? Quadrilateral. Okay, you guys got it. So you remember that chart that I gave you before? If you need to refresh yourself on that chart, go ahead and go back because that's very important here. The first 2 polygons we're going to talk about are a kite and a rhombus. Now, the cool part is they share the same formula for the area, okay? The area of a kite and a rhombus from now on, we will use as 1/2 D1 times D2. Now I want you to look at these two figures. The figure on your left is a rhombus, and the figure on your right is a kite. Someone explain to me what the measurement of D1 and D2 are. What do they represent in these figures? The length of what? What? The base and the height is incorrect. What did you say, Sophia? You didn't say anything? Who said something with a D over here? Not diameter. The diagonals. Guys, the diagonals of your kite are D1 and D2. Now, the formula is such that it does not matter which one you make D1 and which one you make D2, but they are the diagonals. Now, what? They are, but Hannah, they're gonna list them outside the figure, the length of them, because if they listed it in here, it would get confusing. Because if they put an 8 here, right, you wouldn't know whether that 8 was the half the distance or the whole thing. Okay? Second thing, guys, the diagonals of a rhombus and a kite, they both have this property. They form a 90-degree angle where they intersect. So make sure you fill in that 90 for both of them. What questions do we have on this first slide? All of them, yeah, they would all be 90, all those angles. Okay, so now this doesn't necessarily matter, okay? But we are going to prove it because I want to show you where this formula comes from. You're not going to have to do this on an exam. You can just straight up use the formula, okay? So the next, I do want to show you where this formula is coming from, okay? So, no, can you close it? Thank you. It's too bright and then people can't see the screen. Okay, so guys, diameter, no, not diameter. Hayden, when you said diameter, now I have diameter stuck in my head, okay? It's a diagonal. So diagonal 1 and diagonal 2. Guys, the diagonals also bisect each other. So they're cutting each other in half. So what we're going to do is we're going to represent exactly this piece and this piece, where we know that this angle is 90 degrees. Okay? What shape do you see with those two sides and this side over here? What kind of triangle? A right triangle. Very good. Okay? So, what is the length of this piece? We'll call it X for right now. What is the length of X in terms of either D1 or D2? It's half of what? D2. So let's erase the X and let's put half of D2. And then let's do the same thing for that top side, the top side on top. How could we represent that side on top? Half of D1. Very good. Now, we already talked about this in our homework. Let's find the area of this triangle right here. Because you guys agree that triangle repeats itself how many times in this figure? 4. So if we can find the area of that triangle, we multiply it by 4, we should get the area of this rhombus. Let's check it out. So let's find the area of this triangle. So we're going to write area of triangle, I'll abbreviate with TRI, equals, what's the area for a generic triangle, guys? 1/2 base times height, okay? Now, this one's kind of like inverted a little bit, right? But what could we make the base of our right triangle that we drew? What could we make the base of our triangle? Which side could be the base? That you want the hypotenuse to be the base? Okay, but Hannah, do we know any information about the hypotenuse? Other than it's the same length as the other ones, right? And then that would also force us to find a new altitude, right, for the height. What could we use as the base? 1/2 D1. Let's make that our base, okay? So if we make 1/2 D1 our base, let's plug that in. It's 1/2 D1. Remember, we still have a 1/2 out in front. And what can we use for the height then if we make 1/2 D1 our base? 1/2 D2 could be our height. Very good. So let's make this 1/2 D2. No, you were right. You were right. So what can I do here? What can I do here? Can I multiply the 1/2? Sure, I can. What's 1/2 times 1/2? A fourth, and then times 1/2 again? It's 1/8, right? And then we still have D1 and D2, okay? So the area of one of these triangles is 1/8 D1 times D2. Now, let's repeat this. How many of these triangles do I have in my figure? 1, 2, 3, 4. So what do I need to do with this area? If I multiply it by 4, that will give me the area of the rhombus is 4 times 1/8 times D1 times D2. What's going to happen here? 4 times 1/8 becomes 1/2. Is that not the area formula for a rhombus? Boom roasted, we just proved it, okay? Now, you don't have to have this memorized. You don't need to actually know this, but I just want to show you where this formula is coming from, okay? Didn't just poof out of thin air. They separated the figures into right triangles, and they showed that the area of each of the triangles is 1/8 D1, D2, and then they found that, okay, if there's 4 of them, then there has to be 1/2 D1, D2 for a rhombus's area formula. Go ahead, Zach. Talk to me. What questions do we have about this? All right, and then 2 examples is more of what you would see on an exam. So let's move on. Let's go ahead and apply let's apply this formula to 2 examples. So the area of the rhombus, we're going to use the formula, which is 1/2, area equals 1/2 D1, D2. Does it matter which one I make D1 and D2? No. Okay, which one would you like D1 to be? 8? All right, let's make D1 8. And then D2 has to be 6. Plug them in. So area equals 1/2 times 8 times 6. You don't need a calculator for this. What's 8 times 6?
48.
What's 48 divided by 2? 24. Now, be very careful about your units here, peeps. Meters? Squared. Why squared, people? It's an area. It is that easy. No? Bryson? What does the D mean? Diagonal. Okay, so diagonal 1 and diagonal 2. Yes? Why didn't I half it?
Yeah.
I did.
You didn't have 8 and 6.
Oh, remember, you only distribute the 1/2 to one of them, right? You would only distribute if there was a plus sign between the 8 and the 6, okay? So you only half the 8, which becomes 4. Then 4 times 6 gives you 24. Okay? Good question. Yeah, Sophia.
Does it matter which side you put in D1 and D2?
D1 and D2 does not matter, okay? You could have done 1/2 times 6 times 8. You would have gotten 3 times 8, which is also 24. Okay? Yeah, Cody?
Now the 24 meters squared is the whole entire.
That's the area of this entire figure. Yep. Cool beans. Any other questions? These are good questions. Jayo, yes, you can go. Okay. No, letter B. It's a kite now. Do you guys agree? Looks a little bit different than a rhombus. But it's the same formula. Very good, Dylan. So we're going to write A equals 1/2 D1 D2. What do you want D1 to be? 7? Okay. D1 is 7. What would D2 then be? The 10. Plug them in. So it's going to be 1/2 times 7 times 10. 35. Because 7 times 10 is 70. And then divide that by 2, and you get 35. Oh, you'll also have a calculator, guys, so don't feel like you have to do this in your head. Hannah? Very good. Thank you for remembering the units. It's going to be centimeters squared. Okay? Talk to me. What questions do we have so far? So pretty easy formula for kites and rhombuses. Do you guys agree? Cool. How much harder does it get? Just a bit. Just a bit. Do you remember sine, cosine, and tangent? Oh. Yeah, they come back. All right. So, guys, in a regular polygon, what is a regular polygon, first of all? You don't remember? It's okay if you forgot. Yes. What's all equal?
All the sides are equal.
Yeah, buddy. All sides. That's so good, Juan. All sides and angles are, and I'm going to put the congruent symbol, that they're congruent, okay? All sides and all angles are congruent for a regular polygon, okay? So there are some things that we need to go over. We've pretty much already talked about a lot of these, okay? The center, okay, the center of a polygon is going to be the center of the circle that surrounds your polygon. So check it out. Down below, they have what kind of polygon in the middle? What kind of polygon is that? Has 6 sides. What's the 6th one? A what? Hexagon. Very good, okay? So in the hexagon, the center of the hexagon is the center of the circle. What's the center of the circle? Point P. Very good, okay? So point P is also the center of our polygon. The radius of your polygon is the radius of the circumscribed circle. That means go from the center to a vertex. So this length, PM, and this length, PN, are both radii, okay? Your central angle is an angle formed by 2 radii that are drawn to consecutive vertices. What does consecutive mean? Like one after the other, right next to each other, right? So do you see how M and N are next to each other on the polygon? They create a central angle when you draw their radii back to the center. So our central angle here, who can give me the 3 letters for the central angle in this figure? MPN, is that what you said? Yeah. That is correct. You could also reverse the order and put it as NPM, okay? Do not involve Q. Q is a different thing. Q is not part of the central angle, okay? The apothem, this is the new one, star this one. We have not seen an apothem before. An apothem is the perpendicular distance from the center of the polygon to a side. What does perpendicular mean again? Forms a 90-degree angle, okay? So as you notice, which is the only segments that forms a 90-degree angle with a side? PQ. PQ, and list this, is our apothem. Okay? We have not seen that apothem before. Yes?
So is the apothem like the radius?
The apothem is not like the radius. Why isn't it a radius, guys?
Okay, wait. I know
It doesn't touch the edge of the circle. Do you see how it's missing a piece right here, Christian?
Yeah, but I mean, like, is it like in the way that like it goes from the center?
Yeah, it goes from the center to the edge of the polygon, but it cuts the side in half, okay? So guys, some cool things that happen, and you need to write this down. The apothem is going to bisect the central angle. That means 2 angles here are going to be congruent. They are MPQ, and guess which other angle? NPQ. Very good. Those 2 angles will always be congruent to one another. And then the apothem also bisects the side of the polygon. So MQ is the same length as what? NQ. Okay? Make sure you fill those in there. What? Yeah, I can. Is that good?
Yeah.
Anything for you, Christian. You're welcome. Okay, bring it back, bring it back, bring it back, bring it back. So we now have to talk about something called central angles. The central angle of any regular polygon is 360 divided by n, where n is what? The number of sides. So if I'm dealing with an octagon, what is my n value? 8. So my central angle, how do I find the measure of a central angle? 360 divided by 8, which in our calculators, if we plug that in, is 45 degrees. Have we already done this before? I don't remember doing it before. We have done this before? I think what we did before was we divided an arc, right? Because it was a regular polygon, and they were all arcs of the circle, all chords, excuse me. And we divided it by 360, or 360 divided by the number of sides. That was a question we've seen before. Okay. Let me know when you're ready, Amanda. Yes. No. In the diagram, this is a square. Are squares regular polygons? How do you know? All the sides are the same length. Go ahead and throw those congruence marks in there on your figure all around the square. Okay, let's take it step by step. Let's identify the center of the polygon. Where is the center of the polygon? Point P. Very good. Let's list it out here. Center is point P. Where's the radius? What? What? PY is one of them. What's the other one? And PX. Guys, let's be very careful about notation. What needs to go above the PY and the PX? A line like this. Thank you, Carson. A segment mark, which means it stops on both ends. No arrowheads. Dylan? Okay, then we're going to go ahead and list the apothem. QP, very good, or PQ. Also a segment, not a ray, not a line, not a point. PQ. And the last thing is the central angle. What's the central angle? German? XPY. Do we agree with German? Is XPQ a central angle? No, because it used the apothem. Remember, central angles are formed by two what? Two what? Not apothems. Two radii. Very good, Cody. Okay? They're formed by two radii. Yes, go ahead, Cody. Yes, but also you have to use two radii. Okay? Q is part of the apothem. Do you see the difference? Cool beans. All right. Next, we have to find the actual measure of each one. So we need to find the measure of XPY. So let's list it out. The measure of XPY. That was our central angle. Do you guys agree? And our formula for finding the measure of a central angle is what? 360 divided by the number of sides n. In this case, the number of sides is 4. Very good. So we're going to do 360 divided by 4. What's the measure of our central angle? 90 degrees. All right, let's do the next one. We've got the measure of XPQ. XPQ, guys, is this guy right here. If the central angle was 90, what does that angle have to be? 45. How did you get 45? You divided the 90 by 2. So this one's going to be 45 degrees. And what about the measure of PXQ? Where did I get 45 from? Someone answer that for me. German? Which one's an isosceles triangle? XPQ. How do you know it's isosceles? Uh-huh. Right angles make triangles isosceles. Never mind. You're on the right track, though. Remember, we already know, German, that this angle is 45 degrees. How can we figure out the last angle over here? Bryson?
That's 45, and then XY is like congruent. So like this in half.
Oh yeah, it is split in half, but it's split in half with these two. That QY is not part of our triangle, Bryson. Yeah, Hannah? Excellent. 90 plus 45 subtracted from 180. Or you can automatically know, is this a special right triangle? Sure is. It's a 45, 45, 90. So you can automatically assume that that last one is 45 degrees. Thank you. How are we feeling? As promised, we'll stop here. I'll take questions on this slide. Wait, who asked me why it's 45? Sophia, say it again. Which one? PXQ. Sophia, were you cool? This one we knew was 90, correct? Yes. Mm-hmm. Yeah, Gio? Yes, turn this in. Okay, we have two formulas, okay? It's area equals 1/2 times the apothem times the perimeter. But more importantly, we're going to be using the second one, which is 1/2 times the apothem times n times s. Because the other formula that we have is that your perimeter for a regular polygon is n times s, where n represents the number of sides your figure has, and s represents the side length, any of the sides of that figure, okay? And those are pretty much, those and the two formulas before for a kite and a rhombus are the only formulas we're going to be using in this lesson, okay? Now, the reason I like this one more is there's an easy way to remember it too. Because the letters A and S, when you, on your calculator, what does A and S stand for? Answer, right? So just think about it's 1/2 answer, okay? And you'll remember the formula of A and S. And that's for the area of a polygon, okay? A times N times S. Mm-hmm. I'm saying A, not the number 8. Yes. What about it? So it's in that part underneath, right? A and S usually triggers the word answer, okay? So just remember the area formula is related to the word answer, A and S. If it doesn't click for you, then don't try, all right? Okay, that's fine. Then just remember A and S, okay? So we're going to start with letter B. It's a very simple example. It says it's a regular octagon. Stop reading. Octagon is how many sides? What letter do I already know? Not S. N. What is N going to be equal to? 8, right? Do you guys agree? So just write down N equals 8 for an octagon. What if it was a hexagon? What would N be equal to? 6, okay? So as soon as you see what kind of shape it is, put what your N value is. With a side of 5, what variable is now 5? S is equal to 5 because S is the side length. And an apothem of 3. What variable is now 3? Lowercase a equals 3. Remember your formula. We're going to write it down every time. Area equals 1/2 A and S. Do I have enough information to plug in every single value? Do I have A? Little a? Do I have little n? Do I have little s? Plug them in. So area is going to be 1/2 times the apothem, which is 3, times the number of sides, which is 8, times the side length, which is 5. What questions do we have so far about just plugging into our formula? Is everyone on the same page as me as to what we're doing right now? Bryson, you good? I'm good. Okay. So in your calculator right now, go ahead and plug in 1/2 times 3 times 8 times 5. I like to use 0.5 for 1/2. You can do 1 divided by 2 every time. It's whatever floats your boat. So 0.5 times 3 times 8 times 5. Okay. What'd you get? 60? Okay. So area equals 60. I cannot leave my answer like this. Who remembers what I need to put? Scott? No. Don't divide by 2. We divided by 2 in the calculator. Because 3 times 8 would give me 24, times 5 would give me 120. So we already divided by 2, which gave me 60. Okay? But what do I need? What does my answer need, peeps? Elias? Units squared. Very good. Units squared. It didn't give me units, so I'm just going to put units. Christian? We do have to find the perimeter. We're about to do that, okay? So we found the area. The perimeter, right? Remember, it's a regular polygon, so all the sides are the same. All we do is we take n and multiply it by what? The number of sides times, not the area. If there's 8 sides in an octagon, and each side is 5 units, how do we figure out the perimeter of that octagon? It would be 40, but why? What did you do to get 40? You did 8 times 5. So we're multiplying the number of sides times the length of each side, right? So that's where we get the formula n times s. And in this case, our perimeter is going to be 8 times 5, which gives me 40, and it needs to have units. Does it have units squared here? Is it units squared or just units? Just units. Why? It's not the area. Okay? Talk to me. Are there any questions on letter B? So let's do 2 more examples, and then there's a ton more examples. I will cover those in my video, okay? But I will not do them in class. So if you want to try them, okay, for sure, go for it. They're all pretty much the same process. I'm going to show you 2 different examples, okay? But make sure you pay close attention when we go over these in class, okay? All right, so we have a regular hexagon with an apothem of 6. What variables do I know in this problem? I know the number of sides. How many sides are there? 6. So what variable is 6? Little n, not little s. What is little s? The side length, okay? Not the number of sides. N is the number. Think of n number, s is side length, okay? What else do I know? The apothem. What letter is the apothem? Little a, and what is it equal to here? 6. So in my formula, write down your formula. Area equals 1/2 a n s. Which one am I missing? The s. So first and foremost, the previous example was super easy because it gave us all 3 values. Do you guys agree? Letter A is more challenging. So what we have to do, we don't know what the side length is until we draw a picture and set up either cosine, sine, or tangent to figure it out, okay? And I'm going to show you how to do it. You start by drawing a circle. So draw a circle. Inside that circle, guess what shape I'm going to draw? Not a triangle, a hexagon. So draw a hexagon. How many sides does a hexagon have? 6. So draw a 6-sided figure inside your circle. It does not have to be perfect. Then I want you to draw the center of that circle / hexagon. And I want you to draw 2 lines that go to the vertices. Oops. What are these 2 lines considered? What are these 2 lines? They're radii. Very good. They are radii of the circle. Between these 2 radii, does anyone remember what we call this angle? A central angle. Very good, German. There's a formula for finding the central angle. You take the amount of degrees inside of a circle, which is how many? 360. And guess what I divide by? 6. But why? What does 6 represent? The number of sides, which was 6. So we divide 360 by 6, and what do we get? 60 degrees, okay? So the measure of that angle in the middle is 60 degrees. But now you have to draw an apothem. Does anyone remember what are the requirements for an apothem? Yeah? It's got to make a 90 with the side. And what else does it have to do? With the side of the hexagon, okay? So it creates a 90 degree here. The other requirement, Cody?
It's got to make these 2 congruent.
Very good. There's a lot of congruence now that happens. I now know that this angle is the same as this one, and I now know that this side is split up into two congruent parts. So remember, guys, that full angle of the central angle was 60 degrees. What are those two smaller angles now equal to?
Wait, I was gonna ask if it's isosceles.
No, not necessarily. The apothem does not need to necessarily be half the sides, okay? It would be isosceles if it was a 45, 45, 90, okay? So, guys, let's look at the angle. That angle originally was 60. Do you guys agree? And we split it in half. What are each of the pieces? 30 degrees. And we are going to focus on this angle. Now, look back at the original question. Did it tell me the length of any of these segments? The apothem. Which line segment is the apothem? The one going up, the one in red. Do you guys agree? How much was the apothem in this example?
6.
It was 6? Put a 6 there. Now, let's backtrack. What were we trying to find here? The side of the hexagon. Do you guys agree? So let's go ahead and identify. We need to find the side length of this. We need to find the length of this. Agreed? So we're going to split it up, guys. We're going to make this piece right here x. That means this piece on the right also has to be x. Are you guys with me? Does that make sense? Because it's being split into two equal parts by the apothem. We need to set up a trig ratio involving this 30, this x, and this 6 that we know.
30, 60, 90.
We could use 30, 60, 90. I'm going to use sine, cosine, or tangent. Feel free to use whichever one you're more comfortable with. If you're a 30, 60, 90 person, use 30, 60, 90. If you're sine, cosine, or tangent, use sine, cosine, or tangent. Now, I prefer sine, cosine, or tangent. 30 degrees, how is it related to the x? Is it opposite, adjacent, or hypotenuse? Opposite. Put an O next to it. The 6 for the apothem. Opposite, adjacent, or hypotenuse? Adjacent. What trig ratio involves opposite and adjacent? Tangent. Very good. So we're going to set it up as the tangent of our angle. What was the measure of our angle? 30 degrees equals, which one goes on top? Opposite or adjacent? Opposite. What's my opposite side? X over 6. Now, you have to solve for what? X. How do I solve for x here, guys? Daniel? Good. Multiply by 6 on both sides. So we're going to, don't plug it into your calculator yet. We're going to get x equals 6 times the tangent of 30. Let's circle it. Now, a very common mistake, guys, right, Grayson, is that students will think this is the measure of the side of their hexagon, but it is not. Does anyone know why? Juliet? It's only half of it, okay? What we just found was this x value. Do you agree that there's 2 of them that forms the side of the hexagon? So what do you think we have to do with this x value? Multiply it by 2. So watch, we're going to say the side length is actually 2 times my x value. And then substitute in the 6 tangent of 30. So S is going to be 2 times 6 tangent of 30. What is 2 times 6? So the side length is 12 tangent of 30. Now we have our S value. So now let's backtrack to the area formula, and we know every single value now. Let's plug it in. So area equals 1/2. What was the apothem, if you remember? 6. What was the number of sides? 6, because it's a hexagon. And what are we plugging in for S? 12 tangent of 30. In your calculator, you are literally going to type in all of those values. So do 0.5, or 1/2, times 6, times 6, times 12, and times the tangent of 30. What did you guys get? 124.7 is correct. There is units. What units goes on this? Units squared. Why squared? Because it's area. Let me zoom out if you missed any part of it so you can see it. And then this particular question, it also wants us to find what? Perimeter. Hannah, let me find the perimeter really quick and then I'll take your question, I promise. Yeah, go ahead. Okay, so perimeter is just going to be n times s. So perimeter is going to be, what was n again, the number of sides? 6, right? Times, and then the s value I think was 12 tangent of 30. So then we're going to get perimeter equals, multiply 6 times 12 times the tangent of 30, 41.6. What units does the perimeter get? Just units, okay? Daniel.
Did we do the perimeter for the bottom for the number?
We did. Perimeter for the bottom was 40 units, okay? We just did n times s. In that case, it was 8 times 5. What questions do we have? Just start a stopwatch. Letter E, example 3, letter E. This one's a little bit different. Yeah. I'm aware. We're going to get to that. Yep. Okay. So we now have a square inside of a circle. So draw your circle first. Draw your circle. And then draw your square. How many sides does a square have? 4. So what variable do I know right now? N equals 4. Okay. And then it tells us the diagonal of the square is how much? 10? The diagonal of the square is 10 units. Look at the picture. What? No, that's not the answer. So if the diagonal is 10, the diagonal is the same as what length in the circle? This particular diagonal is the same as what length in the circle? The diameter. Very good. So what also did they give us if they gave us the diameter? The radius. What does the radius have to be? 5. So put 5s on both sides of your radii. Now, let's draw one more radius. And let's also give it a units of 5. And let's draw our apothem. So our apothem I'm going to draw over to the right. And I'll make it 90 degrees with the side of the square. Okay. I want to find first the measure of this angle, this central angle. What was the formula for finding the measure of the central angle? Juliet? Very good. 360 over the number of sides. 360 over the number of sides. How many sides does a square have? 4. So divide 360 by 4. What do we get? 90 degrees. So that entire central angle is 90. But remember, the apothem cuts it in half. Do you guys agree? So what are each of these angles now? 45 and 45. So 45 degrees and 45 degrees. Now, we only know the radius, but guys, in our formula, we have area equals 1/2 ANS. We only know one of these variables. Which one do we know? We only know little n. We need to figure out little s and little a, okay? So little s is going to be this entire side length. We'll split it up into an x part and another x part. So whatever we get for x, we're going to multiply it by 2. And the apothem, little a, will be this guy right here. The apothem starts from the center of the circle and goes to the side, and it forms that 90-degree angle, okay? So let's focus in on our angle of 45 degrees. What trig ratio can I set up with the 45 degrees to give me little a? Cody? Tangent? So tangent of 45 is opposite over adjacent. Do you agree? What's opposite the 45 here? X. And adjacent? That would have 2 variables. Do you agree? Let's try something else. So tangent's not going to work for this one. Daniel? So we could use the sine of 45. What would that give me, Daniel?
Opposite over hypotenuse.
Okay, and what's the opposite?
45.
What's opposite the 45?
X.
X over, what's the hypotenuse? 5. So now we can absolutely solve for x. We would multiply both sides by 5. So 5 times the sine of 45 degrees equals x. But that's still not s. What do I have to do to find s, the side length? Multiply it by 2. So this is going to be 10 times the sine of 45 equals the side length. So I have s. It's 10 times the sine of 45. How do I find the apothem? What? Yeah, how do I find it? Let's use another trig ratio. Daniel?
You can't use a never mind.
German?
Cosine.
Very good. The cosine of 45 degrees is equal to little a over 5. Little a over 5. We can do the same thing, multiply by 5 to both sides. You're going to get 5 cosine 45 equals little a. And now we have both our a and our s. All we do from this point, guys, is we plug them into our formula and we find out what our area is. So area is going to be equal to 1/2. What did I find little a was? What am I replacing a with? 5 cosine of 45. What am I replacing n with? What was the number of sides? 4. And what am I replacing s with? 10 sine 45 degrees. Now, all you do from this point is you plug it into your calculator. So go ahead and take out your calculator, do 0.5, because you have to do the 1/2 first. 0.5 times 5 times the cosine of 45 times 4 times 10 times the sine of 45. What do you get? I got 50. What units does it need? Units squared. Why is it squared? Because it's an area. Okay? I'm going to zoom out so you guys can see the whole thing. Yes, Sophia.
Why did you put 10 after sine 45?
Yep, because do you see how on the side of your figure, Sophia, there's that whole side in red is split up into 2 parts by the apothem? An x part and another x part. Do you see that? What we found was we found x, right? You have to multiply that value by 2. So we take the 5, we multiply it by 2, we get 10, right? Sophia, I feel like you're not following. Okay, so do you agree that this side length is what we want to know? We want to know the whole side of the square. What we're finding just now with x is just half of it. Do you agree? So if we multiplied it by 2, now we have the whole thing. Does that make more sense?
You were just trying to find the whole thing.
Correct. But you have to find the whole thing by finding that first top piece and then multiplying it by 2. Does that make more sense?
Would this be on the quiz?
Yes, one question will be like this, okay?